Yeah, there's one thing I want to say about Bayes nets, which is, you know how I was talking about computing their probabilities by going top down? And I said that Bayes nets are a compact way of specifying a full joint probability distribution. You what?
He said, "Don't ruin my end of lecture question."
Oh, I won't. I won't. They're a compact way of specifying a full joint probability distribution. The instant that you let somebody know you've got an interesting probability distribution, the next thing you know, they're going to ask you to sample from it. Like you say, oh, I have this great probability distribution that captures the probabilities of all these different possible events. And they're like, oh, cool, wow, I want to run a simulation where I'm simulating like entire societies growing according to your probability distribution. Please give me a random number selected according to your distribution. And you're like, ah, shit, I'm going to have to sample according to the distribution. So what that means in a Bayes net is give me a random world, but random is like the probability you select that world is according to its probability under the distribution. All right, so like if you give me a weighted coin that like comes up heads 0.8 at the time, then and I say draw from that distribution, you're going to give me either heads or tails, but the probability you give me heads is going to be like 0.8, and the probability you give me tails is going to be 0.2. Same with this. The probability that you give me true, true, false, false, true is going to be proportional to the probability of that world under this distribution. That's what it means to sample according to this distribution. Dan's looking at me like I'm just smoking something. You might not. You might take a whole bunch of samples. Yeah, you might take a whole bunch of samples. It could be somebody saying, I need a picture for my talk. Can you give me a picture of a typical world? So you sample, and you're very likely to get a typical world. So how do I sample according to the distribution here? The probability that I set burglary to true is 0.001. The probability that I set earthquake to true is 0.02. Then I take whatever values those are, and I look here, and I look up, so if we got false and false, then I set alarm to be true with this probability. And then for John, I look at alarm. If it's false, I set John true with probably 0.05. So you like simulating the world top down, figuring out the things that each variable depends on and working your way down the tree. That's how you sample according to a Bayes net. And then the probability that you get some world is exactly the probability that it has under the distribution.
So are there no cycles in Bayes nets?
Ooh, yes. Exactly, there are not. Yeah, because otherwise you'd be, what do you do? How do I go? Like, I can't compute my parent because it depends on me. Yuck. Yeah, that's awful craziness. Yeah, we don't talk about stuff like that in this class. Loopy Bayes nets, they're called. Yeah, we don't talk about that. Sorry. In fact, you can't have them. Bayes nets are always acyclic. Markov random fields, however, where the edges are not directed, then you get stuff like that. But I don't know anything about Markov random fields, so let's not talk about them.
But you could have burglary as an input, both alarm and John call.
Sure. Yeah, absolutely. If you want to.